Alright, I started doing the workshops. So workshop 10 is basically all orthonormalized sets. So there's a recipe and you just repeat the recipe over and over again. So question 1 was orthonormalize this set. I always check to make sure that this isn't zero dot product in the end, so it's not equal to 0, so we're covered. So what I say is I'm going to keep u as my standalone vector, and then I'm going to find v prime, which is a vector that's going to be normal to u. So to do that, I take v prime, I take v, and I subtract the projection of v onto u. So v is 3, 4. I subtract that, so that's the dot product over the dot product of u. And I get this guy. So once I have that, you can then go ahead and multiply it by whatever you need to make it look good. So I decided to multiply by 5 and then divide by 2 to get 2 minus 1. So those two vectors there are going to form my orthogonal set, and my orthonormal set is simply going to be, well, I just calculate the magnitude of this vector and divide by the magnitude. So the square root of 5 in this case, because it's 1 squared plus 2 squared, all square rooted. And same with this guy, he's got the same kind of components. So yeah, so that's the recipe. That's as simple as it gets. So this one is, well, it's in 3D, and there's 3 sets of vectors in this subspace. So let's go ahead and I said v1 is equal to this, which I'm going to call v1 prime. I kind of switched my notation up as I went around here, because I'm going to call the prime ones the ones that are going to end up in this set. So anyway, yeah, that's the guy there. So I'm going to keep him constant. v2, well, I'm just going to take v2 and I'm going to do the same thing I did here. v2 prime is going to be v2 minus the projection of that onto this guy. And that's going to give me this plus this. Get me some arithmetic going. I get this, and I multiply by 3 and divide by negative 2 to get 1, 1, 1 is v2 prime. So v3 prime, you can get that by taking v3, projecting that onto v1 prime. Yeah, okay, v1 prime. And then I subtract the projection of it on this guy. The keynote is do not project it onto him, because you'll not get something that's normal to it. So anyway, you do all your blah 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 arithmetic. I get something like this, and I'm just going to simplify that to this. So that forms the orthogonal set. And then again, you just take the magnitudes of each of these components and divide by those, and that'll form your orthonormal set. You can also distribute that if you want, but it's just messier. Alright, so find this one. Again, checking the dot products here. v2 dot v3 equals 0, so these two are already good to go. So all I need to do, I'm saying v2 prime and v3 prime are just these two vectors. So v1 prime is going to be this one minus that minus that. So I go ahead and project it onto that, project it onto that. I should really use this notation when I write the test. I think that'll come in handy. Anyway, I get the 0 vector. Well, this is a set of vectors. It's a basis, so it has to include the 0 vector. So it's kind of like one of those trivial solutions. So you don't really need it, so you don't bother putting it in there. So then that forms the orthogonal set and the orthonormal set. So that's really the takeaway from this, is when you get the 0 vector, you don't really need to include it. Maybe you'll get dock points, I'm not sure. I mean, it's in there, I guess. Alright, so number 4. Find the matrix representation of the linear transformation from R4 into R4, which projects each vector onto S. So I said S was this subspace here. Now you can just use this as your subspace. And then you just take the identity matrix, the column vectors for in 4D, you're going to have to do it 4 times. You project it onto that. I didn't do this arithmetic. I just refused. Because it's just too much. It just takes forever. You end up with this at the end. Alright? If you believe me, then we go ahead. These are going to form the columns of my transformation matrix. And there's a constant factor, 1/7, so it's nice. You can just take that and put it there. Alright, so that's workshop 10. And I'll do workshop 9 in another video.